yesterday we stopped at question 2, right? Did we? What? Go and take. Okay, we stopped at 2C. So I asked you to go back and finish up 2 pages 52, 53 at least for today. Okay, so let's discuss. Before that, anybody hasn't done it yet? Before I go around checking? Huh? Haven't done which one? When do I do 52, 53? Go to the back. I told you I'll do 52, 53, right? Was it? Okay, sit down. Let's discuss this. But how many of you have done it already? Okay, good. Let's see. A boy pulls a box with 10 newtons along a level floor. The box moves 2 meters. And the frictional force acting on the box is 30 newtons. Okay? Draw an arrow to show the direction of the frictional force. So the motion is towards the right. What direction should our friction be? To the left. Okay, so frictional force is to the left. That is for part A. Label it as F with a little f at the bottom right corner, subscript. Okay, so in order to move the box in the direction of the movement, what is the minimum pulling force that the boy must exert on the box? So imagine, what is preventing the box from moving forward? Friction only, right? And what is the magnitude of the friction? 30 newtons. So in order for the box to be moved, the boy must overcome frictional force. So he must provide a force of 30 newtons also, or greater. Okay, 30 newtons or greater. Minimum 30 lah. Okay. So this label this force as F with a little m. You can draw it over, at the bottom is fine. You can draw it at the rope is fine also. Okay, as long as it is a force on the box to the right hand side of 30 newtons. Okay? So what is the work done by the boy when he pulls the box over 2 meters using the minimum force of 30 newtons? So work done will be all force times, again just distance only, in the direction of the force. Your exam papers, many of you, when you ask for definition, you can come up with parts of it only. You haven't fully memorized the whole thing. So during lessons, when I ask you questions like this, just echo. Just tell me the answer. Keep saying it, you will help to remember. So that you don't have to cram so much memorizing in your brain just before exams. Okay? So work done is force times distance moved in the direction of the force. Not everybody is saying it, so let's see whether you can remember it during the exams. So 30 times 2, you get 60 joules. Next, what is the weight done? What is the work done by the weight of the box? So, weight of the box, what direction is it? Downwards. So what is the work done? So force times distance again. Distance move in the direction of force. Direction of force is downwards. Did the box move downwards? So what is the distance moved in the direction of force? 0. So we will have 10 times 0. Okay, so the full working will be W. W for work done. Work done equals to 10 times 0. You get 0 joules. Okay, you can move your table to the right if the sun is affecting you. So this over here, they are trying to trick you. They say the box moves over 2 meters, but this 2 meters is to the right. It's nothing to do with the weight of the box. Okay. Next. Any questions so far? Then next, a girl lifts a pail of water, weight 20 newtons from the floor. And the pail is raised to a height of 4 meters from here. Oh no, 0.4 meters, raise it up. And she carries the pail at a constant height above the ground and she walks a distance of 1.5 meters forwards. In order to lift the pail from the floor, what is the minimum force the girl must act on the pail? Okay, what do you think? What are the forces acting on the pail? Only the weight, right? So only the weight downwards. So for the girl to bring it up, what is the force that she must exert? 20 or more, right? So the minimum will be 20 newtons. She needs to overcome the weight of the pail of water, which is logical. The heavier it is, the more force you need to exert to overcome it. Drag the arrow to show the direction of this force. Which force? The force that the girl acts. Okay? So, what direction? Upwards. And we need to label it FA. Okay, so now when she has lifted it already, does she still need to exert a force when she has lifted it? Yes or no? Yes. Logically, yes or no? Yes lah. In physics, yes or no? Huh? She needs to exert a force. If she doesn't exert a force, then you'll drop back down. Okay, she's still exerting a force when she's holding it up at a height of 0.4 meters above the ground. Then she starts to walk. Oh no, before that, part B. What is the work done on a pail of water as it is lifted to a height of 0.4 meters? So, her force, what is the direction of her force? Upwards, we have that already. What direction did the pail move? Huh? Upwards, same, right? What's the distance? So what's the work done? Force times distance moved in the direction of force. So how much is it? Work done will be 20 times 0.4. Okay? 20 times 0.4, you get 8 joules. So next, the girl is holding the pail of water. She is still exerting a force upwards. Now she walks a distance of 1.5 meters forward. Is the direction of movement the same as the direction of force she exerts on the pail? The force she is exerting on the pail is still upwards, no change. But she moved forward. So the direction, are they the same? Is the direction of motion the same as direction of force? They are different. What is the direction of motion? Forward. What is the direction of force? Upwards. They are perpendicular. Okay? So note, they are different. So what is the work done by the force on the pail as she walks forwards by 1.5 meters? So right now she is holding a pail of water, exerting a force of 20 newtons upwards, but now she is walking forward. Is there any motion upwards? Don't have, right? So force of 20 newtons times 0, that will be the work done. And the answer will be 0. So right now, work done equals to FA times 0 equals to 0 joules. Don't skip the step. Work done equals to FA times 0 equals to 0 joules. So explaining the answer, why is there no work done? The direction in which the pail moves is perpendicular to the upward force. She's moving forward, but the force is acting upwards. They are perpendicular. So different direction. That is why the work done is 0. Ari, are you okay? Next, a little boy tries to push a heavy cupboard. He uses a force of 400 newtons, but he is unable to move it. So how much work has he done? 0. Very easy lah. No distance move. Okay, so distance move in the direction of force is 0. So you see that there are two ways of explaining it. You can say distance move in the direction of force is 0. You can say, oh no, this is the only way, because the direction, the distance move is 0. Okay, so far? Now I want you to compare this answer over here, part B, 5B with 4E. Both of them, no work done. Okay? But there are two ways that they explain it. Now I want you to copy this over here. The distance moved in the direction of force is 0 at this part also. Okay? Because you can use this same answer to explain the answer in part D. So instead of saying the direction move is perpendicular to the upward force A, you can also say that the distance moved in the direction of force is 0. So this one is more general. It can be used for part E as well. Or just put an arrow here also can. Alright, so next, for work to be done, the following conditions must be satisfied. There must be a force acting on the object, and it must move in the direction of the force. Okay? So those of you who have already done it, just do your corrections. Self-mark, do your corrections. Those who have just completed it, because I've just finished it, also just put a tick against it so you know that those answers are correct. Okay, so next, we still have a bit of time. Let us go on to worksheet 6C. I'll go through some selected questions. Okay? Question 1, you can do it yourself. Question 2, how should we do this? Read the question. What should we write? Can we write KE? You must write kinetic energy equals to half mv squared, then you substitute, right? What is the value of m? 0.2. What is the value for v? 8. We need to square it, huh? Okay. Question 3. Car mass 800 kilograms moving at constant speed. Constant speed, what is the acceleration? Okay. If the kinetic energy is 10 kilojoules, what is the speed? How should we do this? Okay, wait, before you answer, I'm going to call students. Yang Kun, what type of energy is this? What type of energy is this? In question 3. Huh? Kinetic, it is stated here. Kinetic energy. Can you be more confident? So, if it is kinetic energy, what is the first thing you should write? Okay, kinetic energy equals to half mv squared. And kinetic energy, we know it already. It is 10,000 joules because we want to convert it to SI units. Equals to half times mass, right? You say mass. How much is the mass? 800 kilograms times v square. What is v? What does it stand for? Speed. So you have one equation with only one unknown. You can solve for speed. Okay? Question 4. An arrow is shot from a bow at 50 meters per second. What is this? Speed. It is the speed of the arrow, and it has kinetic energy of 125 joules. Find the mass. Okay, so what formula should we use? Afiq? I can't hear you. I can't hear you. Okay, kinetic energy equals to half mv square. You have the kinetic energy already. It is equal to half times mass. Do we know the mass? Don't know yet. So let's leave it as m times v square. How much is v? 50. Square it. You have one equation with only one unknown. Solve it. Easy or not? Okay, converting kilometers per hour to meters per second. You can do yourself. You can do this yourself. Calculate the kinetic energy of the car when it is traveling at 54 kilometers per hour. What is the formula we should use? Jiang? What equals to half mv square? Kinetic energy equals to half mv square. What is m? Okay, 1200. What is v? $54. Okay, everybody agree? What's wrong, Jiang? Okay, don't somebody disagree, yes? Farah and Nadia are not in this class. They are upstairs, IT room 3. Okay, so the speed 54 kilometers per hour. Quite a few of you disagree. Vincent, why do you disagree? It should be in meters per second. Okay, Jiang? Everything should be in SI units. Then you can calculate the kinetic energy of the car. Easy? Quite okay, huh? Okay, so calculate kinetic energy of the car when it's traveling at 36 kilometers per hour. You can also do that. Same formula, change this to meters per second. So, part E, we note that the kinetic energy is reduced when it slows down. What happened to the lost energy? Can it be lost? It can be lost. It can be converted to another form, but it cannot be destroyed. Okay, so where do we lose it to? I heard air resistance. What else do you say? Friction, yes. So we call it thermal energy, okay? This is the thermal energy that is dissipated to the surroundings. You cannot get it back. Okay? Now, question 6. Okay, let me just... So it's been converted to... Let's write thermal energy in the brake pads. As I am discussing with you, feel free to write down notes. Okay? Some of you furiously copying, trying to copy 6A and so on and so forth before I close it. Okay, I'm going to close it already. You're only supposed to copy part E. We're done. Thermal energy. Okay. Motorcycle accelerates uniformly along a level road from rest to a speed of 72 kilometers per hour. Wow. You must be very sensitive with the units. When you see this, must think already. Must convert to SI units later on. In 8 seconds. Mass 400 kilograms travels 80 meters in 8 seconds. See, first one, they ask you to convert. What is the acceleration of the motorcycle? How do we find acceleration? What is the formula for acceleration? Final velocity minus initial velocity divided by Time taken. How much is the time taken? 8 seconds. Final velocity is 72. After you convert it to meters per second, what is the initial velocity? 0, because from rest. Okay? So based on your answer in B, deduce the effective force acting on the motorcycle that moves it forward. Now finding the force based on the acceleration. Something that Gaius said when I asked about acceleration. So what did he say? Do you remember? How do we find the force acting, meaning the effective force are the resultant force acting on the motorcycle that moves it forward? F resultant equals to M A. Do we have A already? Yes, from part B. Do we have mass? Yes, 400 kilograms. So now we have the effective force that moves it forward. Now that we have the effective force, we can calculate the work done acting on a motorcycle. So work done is equals to force times distance moved in the direction of force. Right now I have about 3 people who are always answering me with the last phrase, in the direction of force. So hopefully you guys will be the one to get it correct during the exam. Then the rest, you must try and remember, it is always in the direction of force. You got to calculate the work done. And we have the force. What is the distance moved? 80 meters. Okay? So answer in C times 80 equals to work done. Now part E. What is the kinetic energy of the motorcycle when it is at rest? Kinetic energy when it is at rest. 0. Need to calculate or not? We need half mv squared. V is 0. Speed is 0. So part F, what is the kinetic energy at 72 kilometers per hour? You can do this yourself. What is the gain in kinetic energy of the motorcycle? You also can do it yourself, because you just take the final kinetic energy minus initial kinetic energy, which are your answers in part E and F. Okay? Then consider the answers for D and G. What is D and G? Effective force or work done and gain in kinetic energy. Let you do this yourself also. Okay? Oh, 6C finished already. Okay, so right now you are left with worksheet 6, D, E, and F to do by yourself. No, I didn't say F. Oh, okay. So you have 6D and E, right? But I've already gone through B and C, correct? So, is it fair to say that everybody can submit your work on time